Hi, I'm Dick Kuhn, Chairman of the Board of Lionel Trains Incorporated. I spend a lot of time around the plant here in Mount Clemens, Michigan, and I know the work that goes into making a toy train. I don't mean just the work that goes on over at the administration building where I have my office. I mean every step in the operation, from the person who draws the blueprint to the one who paints the engine. I'd like you to see all the steps involved, from concept to completion. That's the reason for this video. You'll see how we make our most complicated product, a locomotive. And I can't think of a better engine to show than the 700E Scale Hudson. Remaking the Scale Hudson. I get goosebumps every time I think about it.
Lionel introduced the original Scale Hudson in 1937. It was the finest single piece the company had ever made, one of the best made by any toy company anywhere. Modeled after the famous New York Central locomotive, it combined scale model accuracy with mass production performance and economy. It contained an enormous amount of detail never before attempted by a toy train company. The present-day Lionel decided to reintroduce the Hudson only after a lot of research and careful consideration. This is standard procedure at Lionel. It can take over 18 months of planning and preparation before a new item hits the production line. The process, whether for the Hudson or any other locomotive, begins with the marketing group gathering drawings, color photos, and blueprints of the prototype locomotive of the real world or a previously produced model. The engineering department then assigns a design engineer to the project, and a costing engineer is asked to do a feasibility analysis. Manufacturing engineering starts a search for existing tools and molds and solicits price quotes for new tools and molds if they're required. The manufacturing processes and routings are also worked out, how each piece will eventually be put together on the assembly line. Next, the marketing department examines the projected cost to determine if the product is feasible to produce at a reasonable price, in acceptable quantities, and in a timely manner. If it is, the project is then submitted to the highest executive level for final approval. Now other departments get involved. Purchasing gets firm component quotes from outside vendors. Lionel does not make all of its own parts, but an extremely close eye is kept on the quality of the work of outside suppliers. All must submit samples to be evaluated and approved before production quantities are made. The design engineer will build the first prototypes with sample parts. Quality assurance, or QA, begins conducting tests to confirm that the product will perform according to the design specifications. Throughout this period, the molds and dies are checked and fine-tuned. Lionel then introduces the product to dealers and begins to take orders.
After all the months of preparation, there finally comes a time when production begins. And it begins with this. a 22-pound bar of zinc alloy.
That zinc ingot and hundreds of others like it are melted at 900 degrees Fahrenheit at a Michigan die casting plant where the Hudson boilers are cast. The molten zinc is forced under high pressure into the casting tool. The two halves of the tool then open and the boiler casting is removed. It has a cylinder called a sprue attached to it. The casting is dropped into a liquid quench tank, which cools it, goes up a conveyor belt to a trim die where the sprue is removed, and over to a second trim station where excess zinc, called flash, is removed. At this point, the casting still has a seam running along its top. This is called a parting line, the line formed where the two halves of the casting tool meet. Hand sanding and polishing are required to eliminate the parting line, as well as other bits of excess zinc flash. There are 18 separate steps in the polishing procedure alone, and after every step, an inspector checks the work to make sure it's been done correctly and meets the high quality standards of Lionel. After sanding, the casting goes into a vibratory finishing machine. The casting is placed among thousands of tiny ceramic tiles, is swallowed by them, and gets tumbled for 20 minutes. The hard surfaces of the tiles bring a smooth and shiny finish to the boiler. Finally, the casting is dipped in a water-soluble oil bath that protects the casting from oxidation prior to painting. Next, the Hudson casting is taken to a nearby machine shop to be milled and drilled with the holes needed to hold the complicated piping and trim that will ultimately be attached. The casting is placed in a fixture where a computer measures the boiler front. From that precise measurement, it calculates the equivalent of 157 pages of additional measurements almost instantaneously. Then, at two computer numeric controlled machines, or CNC machines, the necessary holes are drilled. One machine puts holes in the cab, 16 of them, and a second machine makes holes that will hold the whistle, the bell, and various wire forms on the boiler. There are 72 of those. The smallest of these holes is made by a single solid carbide drill that is 42 thousandths of an inch in diameter. The frame is milled simultaneously on another machine. By employing the latest computer technology, these machines perform more than 200 operations, doing the work previously done by 30 machines and their operators. This has dramatically improved quality control, reducing defects to less than 0.5%. While the Hudson boiler is being cast, polished, and drilled, the Quality Assurance Department has been busy testing the motor. Six prototype Hudson motors were hand-built for life testing. Each was tested for 100 hours of running time, pulling a flat car containing lead weights, which simulates varying numbers of Lionel rolling stock. In 100 hours, each Hudson locomotive will travel a total of 166 miles. Those are actual miles, not scale miles. During life testing of the Hudson or any other Lionel locomotive, the power is cut periodically so the motors can be oiled. At night or during times when no one is present, the test units are monitored by a computer. If for any reason any train stops, the computer automatically shuts down that track system and notes the precise time the run was interrupted. If any of the motors malfunction, the QA technicians and design engineers analyze the problem, correct it, and resume testing. Once the 100-hour run is successfully completed, there is much more testing which the prototype locomotives must endure. Each is packed in a specially designed master carton and placed on a device called the transportation vibration table, which knocks and bangs it all over a wooden platform. This simulates the movements of a truck traveling at 60 miles per hour over bumpy roads. This abuse continues for 2 hours. Afterward, the master carton is dropped on the floor 10 times from a height of 3 feet. If the contents are damaged in any way during these tests, the packaging is improved and the locomotive is tested again. The Quality Assurance Department was not the only place where tests were being conducted on the Hudsons. Over in the factory, other tests are conducted. The worm gear and linkage are tested to make sure there's no binding so that the linkage moves freely. This is being done in an area set aside for the Hudson project. Here, all the assembly tooling needed for the manufacture of the 700E were gathered together under the supervision of Manufacturing Engineering Manager Steve Ziemba. The tools have been brought over from the tool storage area, where over 20,000 pieces of equipment are kept on pallets stacked in racks 8 tiers high. Of those 20,000 pieces, half are stamping dies and half are molding tools. When the tooling from the original 700E arrived in the Hudson project area, each piece was either approved, repaired, or rebuilt if necessary. Then parts made by these tools were sent to the Quality Control Group, or QC. Once approved by QC, each was returned with a green tag attached. As each component part for the Scale Hudson was produced, reference samples were checked by quality control inspectors, tagged, and placed on a large reference board in the Hudson project area. The testing that goes on here differs from that in the Quality Assurance Laboratory. Prototype parts are tested here not for stamina, as in QA life testing, but for fit, to determine that they will work in production. Hydraulic presses and other machines in the project area are used to assemble these parts. This step of the production process is called sub-assembly. For instance, 4 parts go together to make the scale coupler for the Hudson tender. Putting them together is called a sub-assembly operation done on a sub-assembly line. When the coupler itself goes onto the finished tender, that's assembly done on the final assembly line. Before the sub-assembly line is started, Steve Ziemba assembles the parts. He repeats the process several times before asking the line assemblers to do it. They perform the operation until the most efficient manufacturing method is developed. The procedure is then passed on to the production line staff on the floor. This test run is done with each of the 500+ parts that will eventually make up the finished Scale Hudson locomotive and tender.
One of the problems we encountered when piloting the 700E was that all the handrail stanchions and piping that we see on the outside of the cab have to be secured in place. That's done with small little U-bolts and stanchions, which are all bent over on the inside of the cab. The way old Lionel did that was each one individually was bent over with hand tools. We found that we couldn't do it very consistently and make the rails tight. To get around that problem, we've developed a metal mandrel which we force through the length of the cab, and it bends them over very consistently and makes the rails tight.
Wooden fixtures are often required to hold parts during sub-assembly. Some are even survivors from the day of the original Hudson. Others had to be designed for this job. One of those is a fixture involved in the delicate job of soldering the piping onto the boiler.
The tool makers in our tool room developed holding fixtures for each of the assemblies. This is the booster steam pipe, and it holds each of the individual components in a precise location and also shows line workers where they need to be soldered.
As each sub-assembly of the Hudson is developed and tested, it's stored in a labeled carton in the Hudson area. When all the assemblies have finally been built, they will be used for additional life testing and a practice production run. The Hudson area is right beside the tool room, where manufacturing engineers can readily consult with skilled tool and die makers about problems as they arise and immediately explore solutions. Although inventories of many of the parts required for the Hudson are concentrated around the Hudson area and the sub-assembly area, many more are stored in bins in the computerized inventory control warehouse. Installed in 1990, it contains 47 stocking locations in each of 4 bays. Thousands of small component parts are stored on movable shelves. The computer locates an item by part number, indicates how many are on hand, how many are on order, and how many are available. The computer can also locate the part and deliver it on request. When parts for particular runs are gathered together, whether for the Hudson or any other locomotive or piece of rolling stock, they're ready for sub-assembly. Throughout the production period, hundreds of Hudson sub-assemblies have been completed, everything from the pilot to the trailing truck. Here, a Lionel assembler solders together the injection overflow pipe in union, using the fixture and technique developed by the manufacturing engineers. But while work on the Hudson continues, so does the manufacture of other Lionel products. Much of this starts in the molding area, where injection molding machines turn out plastic parts at an average rate of 1 every 30 seconds. Of the materials that are molded here, the 2 most popular plastics are styrene, used for cars, and ABS, most often used in engine bodies. Plastic pellets are fed into the machines, and thousands of pounds of pressure are applied to mold the now melted plastic into the desired shape. The machines vary in size from 75-6, producing 75 tons of clamp pressure, to huge 375-32s with 375 tons of clamp pressure. The bigger the machine, the bigger the object which can be produced. The smaller machines turn out parts about every 20 seconds. The medium-sized ones turn out cars every 30 seconds. And the big ones turn out engine bodies every 40 seconds. The molders at Lionel are some of the best in the business, having learned their trade years ago in another hobby arena, when Lionel used to make model automotive kits. After molding, many Lionel parts must be painted and decorated. And here, too, Lionel employs a team of experienced production supervisors and operators. First stop for most Lionel products, the paint room. Here, the paint to be applied is matched with a sample paint chip to be certain that the color and type of paint that will be used in production matches the paint that was called out in the original specifications. Then, using a Zinc cup, the viscosity of the paint is measured. If a paint mask is needed for the job, it is first checked for imperfections and then set up. In recent years, Lionel engineers have researched and adopted the best techniques for painting with masks, keeping the colors on a multi-tone paint job from seeping onto one another. On a detailed paint job with a delicate stripe pattern, each mask is used only 4 times before it is changed for cleaning. 2 masks are used alternately throughout the painting process. While one is in use, the other is being cleaned. For simpler painting projects, a painter can complete a tray of a dozen cars before changing the mask. The paint room crew cleans the masks by dipping them in a hot soap solution for 5 to 8 minutes, then blowing off the paint residue with an air hose before repositioning them in their fixtures. Many one-color paint jobs are run through a semi-automatic paint machine. It paints a body shell with multiple spray guns and oven dries the paint. After a car body is painted, it goes to the decorating area. Some products that don't require painting go directly from the molding machines to the decorating area. Here, there are 2 types of machines that apply lettering and decoration: pad printing and hot stamping. Pad printing is the most complicated. First, an etching is made into the surface of the die plate. Ink is then applied, filling the depressions of the die. A silicone pad drops down, picking up the ink, and shifts forward to a precise location directly over the area to be marked. In a swift, exact motion, it drops down and stamps the car. Because this process combines science and art, it must be constantly monitored to be certain the pad contains the proper amount of ink. It also has to be cleaned on an ongoing basis to prevent smudges on the products. The decorating staff knows from experience when to clean, when to apply ink, and how much. The pad printing process can be affected by temperature and humidity. Pad printing is a versatile process, which is used especially on surfaces that are curved or uneven or on riveted areas. It is also the only decorating process used on die-cast locomotives. Hot stamp machines use a rubber silicone die that is pressed against a one-color tape, transferring the ink off the tape and onto the car in the image of the raised area of the die. It sounds complicated, but it is actually very simple and reliable. Hot stamping is used in relatively small areas, primarily in flat areas with little detailing. Temperatures on a hot stamp machine run from 400 to 450 degrees Fahrenheit, thus the name hot stamping. The hot stamp machine is also used for multicolor heat transfers. It transfers the image from a tape that already has multicolor printing on it to a car with heat. It is nearly identical to regular hot stamping, but the difference is the complexity of the decoration. Heat transfer allows Lionel to create beautiful and complex graphics. Some jobs require a mix of both processes. The Northern Pacific passenger car is a good example. Because of the rivets on the green area, each had to be pad printed. The bead, or white stripe, and number were hot stamped, and the logo was heat transferred. The Disney tender has 6 pad print applications on each side and 1 hot stamp, a total of 14 operations, an enormous job for a mass-produced item. The decisions to hot stamp pad print, or heat transfer come out of decorating meetings held many months before each item is produced. There are no snap decisions on decorating Lionel Trains. Quality control is very much in evidence in the decorating department. A supervisor will examine each step in the decorating process, compare it with the blueprints from the art department, and take it to the quality control group. If they approve it, the car is placed by the machine. Each operator has an approved sample to compare his or her work with. In 1990, Lionel acquired a new multicolor pad print machine that will improve the process. The machine can mark a car with 2 or 3 colors at the same time. Older machines could only apply 1 color at a time. Also, in late 1990, the Scale Hudson is almost ready for painting. But first, it has to have most of its exterior trim added. This includes pieces of piping that have long been familiar looking to collectors, who might never have known their actual names. For instance, the booster exhaust pipe assembly and the booster steam pipe assembly, the feed water delivery pipe, the power reverse rod, the injection delivery pipe, the blower valve rod, and those pieces we saw joined by soldering earlier, the injection suction pipe and union assembly. All these are added, as well as more readily identifiable parts and some not so identifiable. After receiving a special phosphate coating that will allow the paint to adhere better, the cab boiler unit is ready for painting. The painting and decorating of the Hudson is less complicated than that of the pieces we saw a few moments ago, but it is no less carefully accomplished, including the delicate job of pad printing the number board. While the Hudson cab gets decorated, its chassis and motor are being assembled. Lionel assemblers have been carefully trained, and there is little wasted motion on the various assembly lines. Some procedures are slower or require more skill than others, and that is compensated for. There are two solderers, for instance. There's a lot of testing: the light bulb connection, the motor when it's added, with the E or reversing unit, with the smoke unit, and finally the entire chassis has to climb a 30-degree ramp in under 5.5 seconds. If any locomotive fails, it is checked and corrected. The chassis will now go to the final assembly line to join the cab. In the meantime, Lionel assemblers have been busy with the Hudson tender. The Hudson tender has been improved in several ways over its 1937 counterpart. The coal pile has been retooled to add detail. Nylon axle bearings have been used on the trucks for quieter and smoother operation. The frame has been redesigned so it can accommodate tighter radius curves. And through the magic of rail sounds, the whistle sounds are more authentic than ever. And now, after years of planning, months of preparation, and weeks of building and assembling, it's time for the final assembly. Carefully, the cab goes down the line, getting a detail added here, another there. Then, at last, it is joined with a chassis and motor. The Hudson is now a working unit. Final details are added. It is retested and tested once again on a loop to make sure it can negotiate 42-inch radius turns as its predecessor could not. It is a magnificent finished product. The work is at last done. The Scale Hudson has returned, better than ever, as the beautiful 1-700E. The 1990 1-700E, a proud part of a long tradition of Lionel Trains. A wonderful tradition that has brought families together at Christmas time, made them just a little bit closer throughout the year, and created collections of heirloom toys that have thrilled children and big kids throughout the generations.